we will have the first part of the Q&A. So again, please type your answer in the Q&A box. If you have similar questions to what is already typed there, you can upvote so it can be prioritized. PA will also be monitoring people from watching at the YouTube live streaming. So if you have questions there, we can also entertain those. All right. So there is first question here in Q&A box from Hill Mendoza. For Dr. Mariano, sir.
Okay.
It says, I am not an econometrician, but perhaps I can consider myself as an applied user of econometrics. So my question may not make sense. Please pick up what you think is relevant. I have a few questions, but each one I think can be quickly answered by Dr. Mariano. Why are packages, what are packages did you use? Can you share them? Did you develop your own codes in R? Are they open source and can share them? Now to my theoretical questions. You presented different models to forecast GDP, growth and inflation. I am particularly interested in the mixed frequency approach, DFM and MIDAS. Which model performs best in projecting GDP growth and inflation? GDP price deflator? Yes, sir.
Okay. I'll let Suleiman answer the questions on the software and the packages used. Let me go to the theoretical question of which forecasting method for which variables. In one of my slides, I pointed out that the DFM and the DFM large will tend to encompass the other methods and therefore dominate the other methods in that sense when dealing with CPI, with inflation. But for GDP and the GDP price deflator, what happened here?
Yeah, we hear you, Bobby.
You can keep on going.
I'll just keep on going. For the GDP and the GDP deflator, the encompassing test that dominates the others would be MIDAS. Suleiman, your comments about the software that were used.
Yeah, the software, we basically use eViews 11. So that's 11, and for the R package for the multiple Diebold-Mariano test or Mariano-Pereira is the R package called MultDM. So MULTDM. That's the R package that is available on our website. eViews is owned by IHS Market, so you have to purchase the software for eViews. So that package includes most of the methods that we have in the paper.
Okay. Okay, sir. Okay, so Hill Mendoza says, thanks. Okay, so we will now move on to the next question from Mike Lucagbo for Dr. Peña. In modeling the lambda, how about using covariates such as hospital beds, cases in the previous day, intervention effect due to policy, instead of or in addition to just the next day index? I have similar question, Edsel.
Yeah, then that's a very important question, actually. The problem there is this. Let's say that we are trying to predict 15 days from now, okay? And let's say that we had incorporated in the model the number of beds on the day. But that might not be available when we are on the day that we are predicting, okay? Like one of the things, of course, that we thought about is to use cases, the number of cases, because that could be informative. But then if you are trying to make predictions 15 days or 30 days ahead of time, we wouldn't have that information for that particular day. So unless we assume certain things, we could actually estimate them and then put a data there, the estimator. But the other problem that we were kind of troubled with is that when we think about the data that are being provided, the number of cases is very unreliable. Even now, I think it's very unreliable. So we said, let's just completely use the data that we think is reliable, and that is the daily deaths that couldn't be cheated on somehow. But the cases could be altered and so on and so forth. So it could also be affected by the number of tests that are being performed. So consequently, it might throw up the model. So the idea that we had is, let's just make it as data dependent with good data that we have we thought that the daily deaths data was the most reliable in that context. You could also use some other things, like you could use the infection rate or the transmission rate or not, and then put that into the model. But then you have to have data to try to estimate that properly. I think a continuous time Markov chain model might perform better, okay, as compared to this, but then you have issues of estimating those parameters in the data might not be there. So we wanted this to be as simple as possible with just the minimum data in the data that we use, just the daily deaths, okay? So that's the reason why we did that. And certainly you could use some other predictors like was social easing introduced? You could put an indicator variable there, but we didn't do that in this case, but you could certainly do that. In terms of the software, because I think somebody was asking, in estimating the data parameter, you could use GLM, and then with the family Poisson, and then the link is log. You could use that. But in the over-dispersed Poisson, you have to create a new function to estimate the psi, and then to estimate the covariance function, and that's the programming part. We could we have that. We haven't put that yet in terms of a package. We are planning to do that or to release it, but we used R. Okay, so in that situation, the plotting was I wrote all the codes on it. It's kind of fun to write codes. Okay, so it sharpens you somehow.
So you're already answering Gil Mendoza's question.
Yeah, I saw Gil.
Yeah.
Question there. Yeah.
Okay.
Yeah.
All right.
Erniel?
Yes, sir.
This is Bobby Mariano. Can I ask a quick question with Edsel?
Yes, sir.
Yeah.
Or are you running out of time?
It's okay, sir. We still have a few minutes.
Okay, one quick question to Edsel. Edsel, if you look at the pattern of deaths, pataas ng pataas, ano?
Yep.
So the procedure for your confidence, your prediction region is always increasing. What I'd like to see is, when can we make it go down?
It was going down actually. Maybe I could share again. I show you. I was running out of time, so I.
Okay, sorry.
Yeah. So could you see something? Do you see
acknowledgement?
Okay.
Acknowledgement.
So you see the acknowledgement. Okay, 1 second. Okay. So. 1 second. Okay. So you could see the thing there. Okay.
Yeah.
You notice that it was going down, and it was going down in the trend, and we were all very happy about that until we opened up everything. And then when I started opening up, you notice that it's increasing again. Actually, when I was predicting things at this point, it was going downhill. And then a few weeks from, I think 2 weeks, 3 weeks ago, it started going up again. And that's because of the easing that we have done, the opening of the business. It's kind of interesting because the data is actually telling us the story of this. one of the puzzles that in the beginning when we did this, we didn't use the day itself, the Monday, Tuesday, and so on and so forth. And so we were getting wider intervals. And then I started noticing a certain pattern in the plots, this wiggly pattern. We thought maybe the day matters. Why should it? But the question is, why should it matter? If I am a COVID-19 patient, I don't have any control of when I'm going to die, isn't it? I couldn't say, oh, let me die on Tuesday. Let me die. So technically, from a theoretical point of view, the distribution of days that people are dying should be uniform on the 7 days. So the question is, why is there a trend? And then it turns out that the trend is because of the reporting. These are reported daily deaths. So somebody might die on a Sunday, but it gets reported on a Monday. Somebody might die on a Tuesday, and then gets reported on a Thursday, something like that. So that's why the frailty, that gamma distributed random variable kind of incorporates the variability that is entering the picture, aside from the day effect. And so when you look at the prediction, you notice that it actually follows the thing there. Yeah, it is very, very interesting in that way. But it's going up. And now I'm very scared of extrapolating too far away, because so many things could happen. And so if you extrapolate 1 month ahead of time, things could just blow up. And I don't think it's proper. Some people, the University of Washington people, in MIT people, they extrapolate too far ahead. And I think it's a very risky thing. Yeah, that's why I quoted Niels Bohr, that it is difficult to make predictions, especially about the future. So it's a risky business for statisticians to forecast too far away. Yeah, especially in this case that the daily deaths or the daily cases is very much affected by feedback loops. Whatever the government decides, it could have an impact on what will happen 1 month from now. So, and maybe because Trump had started wearing a mask, maybe it could help someday. Yeah, so I don't know. Yeah, but it's an interesting data set. It's a very crude way of modeling, but at least it gives us some answers somehow. Yeah, the details are in that archive paper. It's actually we took it as a problem of creating prediction regions for a general Poisson regression model, and then the over-dispersed, and then we just apply this in this COVID thing. So it's quite interesting. It was kind of a challenge, but the tools that we utilized are not very complicated, because it's the delta method, the asymptotic normality, and so on, and that allowed us to do this. But it's an application, nice application to something that is happening. So I thought it's nice.
Okay, we have last question here, the number two of Gil Mendoza's question for Edsel.
Oh,
so
he has part 2, okay? So what is part 2?
Is the concept of prediction region different from the common statistical idea of confidence region? If the same, why not call it as such? What
Okay.
can I deduce from your model? Yeah.
Yeah, confidence regions is when you're building a region for a parameter, like the mean or like the median, for instance. The prediction region, on the other hand, is you're building a region for a random variable. Okay, like what we're predicting is actually a random variable, so it's not fixed. Okay, so so that's why you call it a prediction region. But the principle underlying it is the same. We set up a pivotal quantity, just like what we do for confidence regions or confidence intervals, and then invert that to come up with a thing. But here you're predicting something that is random. So that's the difference. So because you're predicting something that is random, there's an additional variability that goes into the picture, that's associated with the randomness. Just like in a simple or multiple linear regression, you also have the prediction region, which is wider as compared to the mean, the confidence region for the mean function. So you remember in our basic books, the prediction region is a lot wider as compared to just the confidence region for the mean function. And that's the same thing, except here you have a Poisson distributed random variable. And then the question is, how do you do a prediction region for the cumulative one? Some people would use Richard's model. They actually do the prediction itself in the cumulative ones. What we did is to predict daily and then to accumulate. And we exploit the independence of the daily deaths. And then we use the Poissonness of the number of deaths daily. And then aggregate it. And I thought that was a better approach to doing that. Yeah, but it remains to be seen. Yeah.
Final question. Age adjustment in your model?
Mm-hmm.
Is there age adjustment?
Oh, we didn't, because we didn't have that data.
Yeah.
The data that, but you could, data that we have is just the daily cases, and then the daily deaths, and then the daily cases, and then the cumulative deaths. But you could actually do that. You could stratify with respect to the age. And then you could do actually the state by state too. You could also do that. Actually, we told Ben, one of the co-authors there, to look at the state one, because you couldn't aggregate. So I was more interested in the daily one, so in the whole US. And I also look at actually other countries like China, the Philippines. The Philippine data is a little bit suspicious to me, by the way. I'm not sure if we are getting a very reliable data from the Philippines. Because if you look at it, the patterns are simply not there. I don't know. So you're all in the Philippines. You have to.
Okay.
But European data, the European countries' data seems to be okay. But the Asian data were a little bit suspicious to me. But you could try to utilize these types of models, I think, to do that. It's kind of interesting. It's quite nice, yeah, to apply something on a real data set that is changing every day. It's a challenge.
Okay, so we have to thank Dr. Mariano and Dr. Peña for the very interesting talk. Now let's move on to the next speaker.